So I'm just going to show an example for increasing entropy for each of the following. For a decrease in entropy, you could just reverse. Increase in entropy for phase change would be transitioning from a solid state to a liquid to a gas. So if we increase the temperature, so at higher temperatures, greater temperatures, we have more disorder. So that would be tending towards this side of the phases, depending on the melting and boiling points. And the molecules would spread apart as we increase the temperature because of the greater kinetic energies. Lower pressures, there's more disorder, more randomness as we lower the pressure. So if we imagine gas, if we lower the pressure, that allows the particles to expand and occupy a greater volume. And we could see that there's more randomness, more disorder when the molecules occupy more space. Volume, higher volumes. So that's just like the example we showed for pressure. For volume change, we have to make sure that our container can expand. So we might remember the ideal gas equation. So pressure and temperature are inversely related. So generally, as we increase the pressure, volume decreases and vice versa for a constant moles and temperature. Quantities on opposite sides of the equation are directly proportional. So as we increase one, the other would increase. Lastly, the number of moles. For higher numbers of moles, we would increase the entropy. So imagine some equation like A plus B makes C plus 2D. We can see that there are 2 moles on the left side and a total of 3 moles on the right side. So as we increase the number of moles in the container itself, you can see that we create more disorder. If we start at 2 moles, this will occupy a certain volume and exist at a certain pressure. As we increase the number of moles, the volume would increase if the container was allowed to expand. So basically, this is a greater entropy if the container can expand.